Welcome to our lesson today. We are going to proceed with calculus, and specifically, we are going to look at the stationary points of a curve. We have three sets of stationary points of a curve, and they can be illustrated uh, in this diagram, right? Uh, Point A, B, and C are stationary points or turning points. Stationary points can also be called the turning points. You can see the curve is turning at point A, it is turning at point B, and it is also turning at point C. Now there is something that is very particular here about the three turning points. One of them is moving uh, from a positive gradient to a zero gradient and then to negative gradient. This one is turning from a negative gradient 0 to a negative again. And this one is negative 0 to positive. So I'm going to say the gradient here, and the gradient, as we know, is dy dx. dy dx here is greater than 0. dy dx here is 0 because it's the turning point. If you have a tangent line here, it will be horizontal. So dy dx is 0. dy dx here is less than 0. Dy dx here again is 0. It's 0. dy dx here is less than 0. dy dx here is greater than 0. Then of course dy dx here is 0. What I'm doing is, at any particular turning point, dy dx is 0. Why is it 0? Because there's a little bit of a straight line there, right? The tangent there is horizontal, and when the tangent is horizontal, any horizontal line has its gradient as 0. Now, I'm going to very fast uh, say something. I'm going to say that, of course, we know that at the turning point, dy dx is 0. We must have said that in our previous video, all right, when we were talking about equation of the tangent to the curve and equation of the normal to the curve, right? So we are saying that we have types, three types of stationary points. We have the minimum, we have the minimum, we have the minimum, and the minimum looks like this. That is how the minimum looks like, like A. Part A is a minimum, where dy dx is less than 0, of course, becomes 0 at the turning point, and then becomes greater than 0 in the end. That is a minimum, right? So we're going to say the point at which uh, gradient changes uh, from negative through positive, through 0 to positive, is the minimum point, right? If the gradient changes uh, from negative through 0, of course, through the turning point, you see here, the gradient is negative, it becomes 0 at the turning point, and then it becomes positive in the end, then it is a minimum point. Then it is a minimum point. I'm going to the maximum point. I'm going to the maximum point, and I'm going to say the maximum is a little bit it's pretty much the opposite of a minimum point, which looks like this. When the gradient changes from a positive, that is greater than 0, through 0 at the turning point. At the turning point dy dx is 0. The gradient is 0 to a negative where dy dx is less than 0. This is a maximum. It's a maximum point. So you can say that the point the point at which gradient changes from positive through 0 to negative is called the maximum point. Now, finally, I want us to go to the third nature. I want us to go to the third nature of stationary points. The third nature is called the point of inflection. The point of inflection. The point of inflection is when we have a negative gradient, it turns to 0 and then continues being negative, or a positive gradient becomes 0 and then proceeds being a positive. You see here dy dx is greater than 0. Here it is 0, and then it proceeds to being greater than 0. And of course, the opposite also happens here. Dy dx is less than 0. Here, the dy dx is 0, and it continues being less than 0. Then in this case, this is the point of inflection, where uh, the gradient uh, uh, remains the way it was after turning. And we're going to very fast go to our first example. Let's go to our first example so that we learn how to answer questions. And my first example here is going to be find the stationary points. Find the stationary points and sketch them. Of course, for the following functions. Number 1 is going to be y is equal to 4x minus x squared. All right. Solution. The first thing we are going to do is to find the stationary points. Find the stationary points. And then after finding the stationary points, then we can now go ahead and determine their nature. All right. Now we know at stationary point, dy dx is 0. So our job is to simply find dy dx, because we know y is 4x minus x squared. So dy dx will be equal to minus 1 there, so that we have 4 minus 2x. If you do not know how to differentiate, you can go back to our previous video so that you can learn how to differentiate before you proceed to this. All right. So, and then we know that at the stationary points, this dy dx is supposed to be 0. So we just equate it to 0. So 4 minus 2x is 0. We'll take the 4 to the other side, so that negative 2x will be equal to negative 4 over 2 over 2 over negative 2. Then x becomes 2. Right? So our turning point is when x is 2. Right? The turning point is when x is 2. right? So when x is 2, what is y? So y is 4 times x minus x square, right? So y becomes, and x is 2, x is 2, x is 2, x is 2. Now we are substituting x with 2. So this is 8 minus 4, and therefore y is 4. So the turning point is 2, 4, right? That is the turning point of the stationary point. So we are going to go to the second step. We are going to go to the second step, which is, or the second part of the question, which is sketching, right? So what you're going to do is simple, right? We're going to have our x. We're going to form a table. All right, all right, all right. So we are going to have a table, and in this table we are going to have x, and we are going to have dy dx, and then we are going to have another row here for diagrammatic representation, right? Going to have another one for diagrammatic representation. And then I'm going to have my value of x here in the middle. And my value of x, I'm going to say dy dx is 0. Why? Because remember, at when x is 2, it's the turning point. And we know that at the turning point, dy dx must be equal to 0. All right? And then we're going to take the neighborhood of 2 both from the left and from the right. And what is close to 2 in the left hand side? 1 is close to 2 in the left hand side. And what is close to 2 in the right hand side? 3, right? So we are going to just put the 1 in our dy dx and the 3 in our dy dx, and we check whether the sign is negative or positive, right? Because we know that when the gradient is negative, it looks like this. When the gradient is positive, it looks like that, right? So very fast, our dy dx is right here. The equation for dy dx is right here. So dy dx is what? Dy dx is when 1, when x is 1, dy dx will be what? Dy dx will be 4 minus 2 times 1. So that is 4 minus what? Minus 2, right? That is positive 2. So if the moment it's positive, then the curve should be looking like that, right? And then what about this one? When x is 3, we're going to have 4 minus 2 times 3, and that is going to give us 4 minus 6. And therefore, it's going to be negative 2, negative 2, right? So if it is negative 2, then it looks, obviously, it looks like this, right? Right? I hope you remember that. I hope you remember that. And then, with that, we can conclude the nature of the stationary points that we are having. What is the nature of our stationary points? Just take a second to answer, and then we'll confirm with the answer. So I'm going to say that the nature is a maximum. The nature is a maximum. Why? Because we have a negative going through 0 and then a positive, right? We have a negative going through 0 and then a positive, and that one, as we have discussed, is a maximum stationary point. And as far as the sketching is concerned, now for you to sketch, you need the values for y. You need the values for y. You need the values for y. Now remember, our equation was looking like this. Our equation was looking like this. Y is equal to 4x minus x squared. So we just need to put 2 in so that it becomes 4 times 2 minus 2 squared. That should give us 8 minus 4. That is 4. Right? We need to put 1 inside. So 4 times 1 and then minus 1 squared. So that should give us 4 minus 1. That is 3. Right? And then we need to put 3 also. 4 times 3 minus 3 squared. That is 12 minus 9. And that gives us 3. Right? And then we plot that 1, 3. Let's say this is 1, this is 1, 2, 3. So 1, 3 will be there. 0, 4. 4 is going to be somewhere there. So 0, 4 is there. And then 3, 3. 1. There's a mistake there. Sorry about that. Remember we are plotting x and y. Remember we are plotting x and y. The job of the dy dx was to tell us the nature of the stationary points. And they wanted us to practice that because sometimes they just tell you to state the nature of the stationary point, and therefore you might not need to sketch, right? If you're given to sketch, if you're asked to sketch, then you can just go directly and get the value of x and y, and then that will tell you the nature of the stationary point. But if you're not told to sketch, you can simply you can simply get the dy dx, and then using the signs that you get, you can tell whether it's a maximum point, a minimum point, or a point of inflection. So the first point is 1, 3. So 1 is there, 3 is there, right? Then we have 2, 4, which is apparently the turning point. 2 is there, 4 is up there, and then it has to turn. And then we have 3, 3. 3 is there, 3 is there. So that is how your sketch will look like. And you can see it's a maximum point. All right? For the people who just want to remember very fast, you can just say U is a minimum point, inverted U, or N is a maximum point. And it is pretty much a basic thing to remember. Now I'm going to show you another method. I'm going to show you another method for finding the maximum and the minimum. To find the nature of stationary points. Method 2. Method 2 for finding the nature. And to be very clear, you can only use this one if you are neither asked to have a diagrammatic representation nor asked to sketch the curve. Right? Because if you're asked to sketch the curve, then you must have a dy dx, right? If you're asked to sketch the curve, you must have a y and x, because those are the points that you're going to plot. But if they have just asked you to find the nature of the stationary points, you can just go ahead and use method 2, and it is simply find the second derivative, right? After finding the second derivative, if it is negative, then it means a maximum. If it is positive, then it means a minimum, right? Like for our case, our equation was y is equal to 4x minus x squared. The first derivative is simply dy dx or y prime, right? You don't need to use both of them, you just need one. You either say y prime or you say dy dx, which gave us 4 minus 2x, right? To find the second derivative is to just differentiate it the second time, right? Differentiate it the second time to get either y prime prime if you are using y prime, or you get the d squared y over dx squared. So you just differentiate it again. If you differentiate this, of course, this will disappear. And of course, this will also be x to the power of 0. So you'll have negative 2. And I insist, if you still do not know how to differentiate, go back to our previous video where we were handling how to differentiate, right? Now, because the second derivative is a negative, then therefore it's a maximum, right? And that's it. I'm thinking of having another example, on the same, so that we do enough practice. So let us have another example of the same. Find the stationary points and sketch the turning points. Let's have another example. So find the stationary points. Find the stationary points for the curve y is equal to 2 plus 3x squared minus x cubed, and sketch it. This is another nice question. So step one, as usual, we are going to say at stationary points, dy dx is 0. So very first you're going to get the dy dx. dy dx is, drop the 2, so you have 6x minus 3x. That is dy dx. And you're going to, 3x squared. Right. So the derivative of that equation is what? 6x and then minus x squared. So this one is equal to 0 at stationary points or at the turning points, right? So let's get the values of x at the turning points. 3 is common and x is common in both cases. So I'm going to put 3x outside. 3x will be equal to 2 minus uh, uh, minus x, right? Right, so 3x into 2 minus x, I've just factored out 3x is equal to 0. So 3x is equal to 0. That means x is 0 because if you divide both sides by 3, you're going to have x is equal to 0. And 2 minus x is also equal to 0. So negative x is negative 2. And you divide both sides by negative 1. Therefore, x is equal to 2. So in this case, we do not only have one turning point, we have two turning points. And this is interesting. This is very, very, very interesting. All right. So we have two turning points. The first one is when x is 0 and when x is 2. We can uh, very fast get the points. Can very fast get the points. So when x is 0, what is y? Y inakuwa 2 plus 3 times 0 squared minus 3 cubed. So y is 2. And then when x is when x is when x is 2, when x is 2, y becomes 2 plus 3 times 2 squared, and then minus 2 cubed, right? So y is 2 plus 2 squared is 4 times 3, 12, and then minus 2 cubed is 8, right? And 12 minus 8 is, 2 plus 12, that is 14. And then 14 minus 8 is 6, right? So y is 6, right? So we have two stationary points here. We have two stationary points here. We have the point 0, 2, and then we have the point 2, 6. Because when x was 0, y was 2. And then when x was 2, y was 6, right? So I'm going to not go to the neighborhood part, because already they have told us to sketch the curve. So whether we go to we go finding the neighborhood of the stationary points or not, we are still going to have to find y, so that we sketch the curve. So very first I'm going to have my table there, and I'm going to say x, y, right? Hey, all right. Now we have these 2 points that we're supposed to sketch, and we have the point 0, 2, right, and the point 2, 6, right? So uh, when x is 0, of course y is 2, and when x is 2, y is 6. You just need the neighborhood, let's say 1, and then, negative 1, and 1, and 1, and 3, so that we know how this curve looks like. Alright, so very fast, this is our equation. So y is equal to 2 plus 3 times 0 squared minus 0 cubed. Oh, this is what gave us 2, the one that we have here. Then y is 2 plus 3 times 1 squared minus 1 cubed. We are looking for this. So this is going to be 2 plus 3 minus 1, right? 1 cubed is 1. So this is 4, right? So we're going to have 4 there and 4 there, because the same. And then negative 1. So y is 2 plus 3 times negative 1 squared minus negative 1 cubed, right? So 2 plus negative 1 squared is going to give us 1. So plus 3, and then minus negative 1 cubed is going to give us negative 1, right? So the negative and the negative is going to give us a positive. So we'll have 2 plus 3 plus 1, that is 6, right? So we're going to have 6 there. And finally, 3 is going to have y is equal to 2 plus 3 times 3 squared minus 3 cubed. Alright, so this is 2 plus 3 squared is 9. 9 times 3 is 27. And then 3 cubed is 3 times 3, which is 9 times 3, that is 27 again. to y is 2. Alright, and you're going to have a pretty much more accurate curve than mine, but it simply looks like this. It's negative 1, 1, 2, 3, 4, 5, 6. So 6 is somewhere there. Alright, then we have 0, 2, 1, 2, 2 is somewhere there. Then we have 1, 4, so 1 is there. 1, 2, 3, 4, 5, 6, so 4 is there. Alright, so this is a turning point already because the curve goes like that. Alright, and that tells you that 0 is a minimum, right? Because you can see the way it's turning. So 0 is a minimum. Alright, then let's continue plotting. 1, 4. 1, 4 is there. I think it's at the same point. We're proceeding now with this one, 2, 6. So that is 3, 1, that is 2. So 2 goes to 6, somewhere there. And of course, that is all for turning points. And then we have 3, 2. 3 is somewhere there, and 2 is there. So it goes like that. And therefore, that one is a maximum turning point. So that is our stretch, and you can see we have a minimum and a maximum. So these are sometimes you might find that you have two turning points in the same curve, because a curve can turn two times. I'm going to make another video with more examples on the same. So stay tuned. Find the other. Thank you, and I hope this video was very helpful.